Alright, this is a worksheet that is going to teach two algorithms, or have you practice two algorithms. One algorithm takes a regular expression and turns it into a finite state machine. The other takes a finite state machine and extracts from it a regular expression. And together these two algorithms are parts of a constructive proof that if you have a regular expression for a language, then you can have a finite state machine for that exact same language, and vice versa. That anytime you have one, you can have the other. Now the algorithm that we're going to learn first will take a regular expression and turn it into a finite state machine. Finish donging. So here's what we do. We have a regular expression in mind that we would like to have a finite state machine for that does the exact same thing. So we start by making two states. One is your start state, the other is an accept state. And you draw a great big long transition between those two states, and you write the regular expression that you want to make a machine for on that transition. So at the beginning, our machine looks a little strange. It doesn't have single letters labeling its transitions. It has chunks of regular expression labeling its transitions. So it's not technically a finite state machine until we get all the way to the end. But what the algorithm does is work on that problem that the transitions have funny labels by breaking down a transition into its constituent parts and repeating this process until every transition does indeed have either a single letter, letters separated by commas, which we allow in finite state machines, that means an or lambda. We will produce a non-deterministic finite state machine with this algorithm, but we know how to take non-determinism away. We have an algorithm for that too. So let's look at the steps of this algorithm that are printed right here. I've already told you have to make a start state and an accept state and write the regular expression on a single transition that goes from the start to the accept. Then this number 2 is important. It says until all of the transitions of the machine have nothing on them but lambda or one character from the alphabet, and we're fudging a little because we do allow A, comma, B, but that didn't say so. Or one character from the alphabet, do the following. Step A, find a transition that contains a regular expression instead of a single symbol. If it contains an outer OR, which means an OR that's not nested inside a set of parentheses, break it down using the OR operation. Else, if it's the concatenation of more than one element, break it down using the concatenation operation, which I'll go over in just a second. Else, use the star operation to break it down. If it isn't one of the first two things, it has to be something starred. Okay, notice that we did those in reverse precedence order. We first look for OR. If there isn't one, we do concatenation. If there isn't one, we do star. Now, here's how you do OR. If you have a single letter ORed to another single letter, then you just make a comma in between them. If you have something other than single letters that are ORed together like this, well, then you actually draw separate transitions from the state, the first state to the second, and you label each transition with one of the pieces that's being ORed together. You could do that same thing up here. You could make one transition for A and one transition for B. It's just that we're not really in the habit of doing that. But it's not wrong. You could do that and it'd be perfectly fine. So that's how you deal with OR. Notice that no new states get added. If you have two states with a transition between them that contains some sort of an OR, the thing you do to get rid of that OR transition label does not produce a new state. The others are going to make new states. So let me scroll down and I'll show you the concatenation operation. Suppose you have an expression on your transition that has bunches of things being concatenated together, like this A or B star concatenated to an A, concatenated to a B, then an A, and then a parenthesized expression that has stuff in it. So we have one parenthesized and starred expression, that's one thing, then an A, a B, an A, that's three more making four, and then this one last thing. That's five things here that are being concatenated together. So what we do is we break that up into five pieces that are arranged on a backbone in the right order, in the same order that they were in right there. So we have the first piece, A or B star, between these two states. We have to add this new state, this new state, this new state, and this new state. This is the same state as that, and this is the same state as that. But all these others are new, and we put them in there so that we can separate out the things that are being concatenated together. Now, this may become clearer as we do examples. Let's look at what happens with a Kleene star. This seems kind of strange to most people at first. Suppose that your expression that you're trying to break down is a big parenthesized Kleene star thing. It might not even be a big parenthesized. It might be a single letter with a Kleene star thing. But what you do in every case, you put one new state in between the two original states. You make a lambda transition to that new state and a lambda transition away from that new state, connecting your two original states. And you put a loop on that new middle state that you created and put everything that was starred, and in this case, since it was a parenthesized expression, you're simply taking off this outer star. Now, you're not dealing with this inner star yet. This has to do with fixing this outer star and getting rid of it on our transition, and so you put everything that was being starred on that loop. Now, this loop is not finished yet. We still have work to do to break this down, but at least we got rid of that one outer star. Now, those are the rules, so let me go through an example with you and show you how those things begin to take shape when you're solving the problem of turning a regular expression into a machine. Okay, our first example is this string, or this regular expression, for strings that do not contain BB. Any string that doesn't have two B's in a row. All right, and that's what this is supposed to make. So let's see if we believe that. This piece right here is starred. So you can take an A anytime you come into this starred part, or you can take a B followed by an A. This A is kind of a separator, isn't it? It keeps you from grabbing two B's in a row. So you can take as many A's in a row as you want, but every time you take a B, you have to have an A after it if you're using this piece. And at the end of your string, because you might want a string to end with a single B. It can't end with more than that in B's, because then it'd have a BB, but you can tack on one more B if you want to, or you can tack on nothing. So I believe that that is indeed strings that don't contain BB. Okay, now it says help. Start with concatenation because the ors are both contained in parenthesized parts. Once you break apart the concatenated pieces, you no longer need the parentheses on the second piece, and you can do the or. The first piece, however, will need to have star applied to it, and then or, and then finally concat on the BA. Show all your steps so I can check it. Okay, so that's what we're going to do here. So let's draw our starting state and a transition long enough to write that regular expression on, going to an except state. And on here we write A or BA star. Okay, A or BA quantity starred, followed by quantity B or lambda. That's step one. Now we remember the order we have to apply these things in. First we see if there's an or we can get to. Then, if not, we do concat. And if we can't do concat, then there has to be a star, or else we're finished. So let's see. Um, there are no outer ORs. There's that little OR and there's that little OR, but both are inside sets of parentheses. So we can't do OR, not yet. Can we do concatenation? Are there things here that are being concatenated together? Yes, there are. There's this piece with a star, and there's this piece without a star, but there are two parenthesized expressions being concatenated. And remember, when you do concatenation, you bust them up and you put them on a backbone. And so there are only two pieces. We're just going to need one new state to make a backbone with two vertebrae. How you like that? Alright, so first piece, A or BA quantity star, goes right here. All we're doing is breaking apart the two concatenated pieces. We're not changing them in any way. We're just breaking them up. Alright, now we take each of these separately and do the same exact thing. This is very recursive. We keep doing it until every single transition in the machine is a single letter, letters with commas, or lambda. So let's look at this one. There is no OR that we can get to. The OR is buried in parentheses. There's no two things being concatenated together. There's this star thing, so we have to get rid of that. Now, we're not going to be dealing with this piece right now. We're just dealing with this piece. And so when you do star, you add one state in between the two original states that you had. And so that state right there is this one. And that state right there is this one. And in between there, we put transitions with lambdas on them. So there's going to be a lambda right there, and there's going to be a lambda right there. And then we put a loop on this middle state. I'm kind of squishing this because I don't have a lot of room here. You're going to get rid of that star. See, that 0 or more is taken care of by the fact that you can go around this loop 0 or more times. You don't have to go at all. You can go straight through. But if you want to, you can pause here and go around this loop. So we take off the star, but we keep everything else, which means we end up with A or BA on that loop. That finishes this piece. Now what do we do here? Well, you know, we didn't really need those parentheses since there wasn't any reason to have them. Before, we wanted to be sure that that OR was that the precedence of that OR was raised by separating it from this here and not letting that B bind tightly to this. And so we had a need for those parentheses, but we don't have a need for them here. So really we could have omitted them when we wrote this. So what we really have here is B or lambda without the parentheses. Maybe I should just go ahead and erase them while my clock dongs. Unfortunately, it's 7 o'clock, and so my clock is going to be donging for a while. But while it's donging, we'll go ahead. So now we have B or lambda here. Remember what you do with OR? You don't add new states, you just make extra transitions. And so we're going to have the same number of states. Now, if you'd like, you can put B comma lambda. If you don't like, you can make a transition for B. You make another transition for lambda. Up to you. I think I'll put B comma lambda, meaning B or lambda. Okay, so now this transition is fixed, so is that one and that one, but this one is still not a single character. So we have work to do. Now what operation do we need to apply to first break this one down? Look at them in this order over here. First look for OR. Do you have an OR in here that's reachable, that's not buried in parentheses? Yes, you do. It's that one right there. So that's what we have to do first. We have to break that down into two transitions. Now when you are doing this on an exam or something, you don't have to really do all these individual steps so carefully. It gets old. So you just do some of this in your head. But right now, I'm being very careful, so I'm writing it all out. Okay, so we have an A being ORed to a BA. So we need to separate them. We'll have one loop for A. We'll have one loop for BA. And we are almost finished. And I'm almost out of room on this little screen here. So if you will allow me, I'm going to take a shortcut and not redraw this whole thing. This is the only transition that remains a problem. It doesn't have an OR in it, but it does have concatenation. And so what I really need to do is make a backbone for BA, which means I need one new state. But look where this backbone starts and ends. It's a loop. And so here's what we have to do. Remember BA, so we can fix that back the way it was supposed to be. We need a new state in between. So that backbone is going to look like this. We're going to have a B coming to a new state and an A coming back. And that's our finished machine for that regular expression right there. Now let's do another one. Alright, this is a regular expression that looks kind of interesting. We have two things being ORed together here. We have A or B star followed by AA followed by A or B star. So that's a substring, any string that contains AA. But that's unioned with, using this OR, what is this? We have outer parentheses and a star. Inside we have an A or B followed by an A or B. So it's, you know what it is? It's even length strings because you get two letters in here. You take an A or B, then you take an A or B. So it's like saying AA or AB or BA or BB quantity starred. That's what this is doing. So either strings that have an AA in them or strings of even length is what this regular expression is making. And here for a hint it says you can change A or B to A comma B since they are both single characters. Alright, well let's get started here. We'll make a big long transition because it's a big long regular expression. That's a very wavy transition. Okay, so we'll make A or B star. That hint comes later. Followed by AA, followed by A or B star. Or A or B, A or B, whole thing starred. Now, just as a little reminder, first look for OR. If you don't see one, look for concatenation. If you don't see one, look for star. So here we have this OR. You can't get to these ORs now. You can't just use any old OR. You have to have an OR that is ORing pieces of the whole, not little ORing little sub pieces. So we can break this from this. Remember with OR you don't make a new state, you just make a new transition. So we still keep these two states, but we're going to have a transition for the first piece and a separate transition for the second piece. This first piece, A or B star, followed by AA, followed by A or B star. And the second piece, A or B, quantity, start. Now let's do the top one. Is there an OR that we can get to? No. Are things being concatenated together? Yes. How many? 4. A or B star, A or B star. So let's do that top road. Make a spine. It has 4 chunks. So there's the first one. Actually, that first one better be a little longer because that's an A or B star. I need a little bit more room. It'll be A or B star, then here's an A, and another A, and an A or B star, down to that same old except state that was up there. So here's A or B star, followed by A, followed by A, followed by A or B star. Now the bottom road, this one, these ORs are inside parentheses. I can't do them. And the concatenation of these two pieces is inside this big star thing. So I have to get rid of the star first. Now remember, star always has you add one extra state. Here's my funny looking one extra state. We have lambda to it and lambda away from it. And then we make a loop on it, and you write everything except for this star, and we no longer need those outer parentheses. So what we're going to write on here is A or B followed by A or B. And now some things are done. These two A's are done, these two lambdas are done, but that piece is not. So here's what we have to do. I'm going to try and put all of the fixed in this one little bit of room that I have down here. So here's my start state. Here's that state. To get rid of that star, which is what I have to do next, I have to put a state in between there. I need a lambda going to it. I need a lambda going away from it. And I put a loop to get rid of the star. Here's where the hint comes into play. It says you can change A or B to A comma B. So that's what we're going to do. We're going to put A comma B right there. So now this piece is done. We need an A. Now we need another A. We need to do that very same thing again out here. So there's my except state. I need a new state in between to get rid of the star. Lambda, lambda, loop, A comma B. All right. Now, just for a second here, let's see if what we're doing makes some sense. It's always good to take a step back and look at the big picture. Does that machine part right there make you think of this regular expression? Does it look like it would do the same thing, that it would accept the same strings that this regular expression can generate? Anything at all followed by AA followed by anything at all? Let's look. Well, yes it does, because you can free slide over to here, then do anything at all. A, B, 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 A, whatever. Then you move over here. Then you need two A's, so there's the first one, there's the second one. And then you free slide over to here, do anything at all, and when you've finished, you slide over to your accept state. So that's big picture, and it's good to just step back and think about it for a second. All right, now we've got to fix this bottom road. And we've got two lambdas with this funny looking thing right here, and I am so not going to have enough room, but I'm going to try. So I'm going to really crowd this up. Here's my lambda going to that state, and here's my lambda coming out of it. Now this big loop, does it have an OR I can get to? No. Does it have concatenation? Yes, it has this parenthesized thing concatenated to this parenthesized thing. Concatenation means that you have to bust them up and make a backbone out of the two of them. So what I need is another state. I'm going to squish it in right here. I need the first A or B going to that one and the second one coming back. So an A or B can turn into A comma B. So I can actually be finished after this. A comma B going back. And we're finished. That is the non-deterministic machine that our algorithm makes for the regular expression that we started with. All right, here's the next one. This is the last one that the worksheet has you do for this algorithm. Then it goes into the other algorithm, and I think we'll just put that off until we get back together again. But let me just get you started on this one, and then I want you to finish it by yourself to test how much you really understand here, so you'll be ready to ask questions if you need to. This regular expression is one that I'd like you to be familiar with. It is for the same strings that our even machine accepts, strings that have an even number of A's and an even number of B's. Remember that that machine had 4 states, that the start state was the accept state for even. And this is the regular expression that generates those same strings. Now how does this generate that? Well, we've looked at this piece before. This piece has a length 2 string that gives you one A and one B right here and right here. Those are mandatory. There is no star on them. The center portion keeps you even length because you take 2 at a time, but for the center portion you're taking double letters, either 2 A's or 2 B's. This whole piece right here makes strings like let's list a few of them, just that you can make from this piece right here now. You can make ABBA. You can make BA, AA, BB, and then BA again. So you're going to, with that piece, you're going to have a different 2 letters, B and A, on either end, and possibly you're going to have some double letters in the middle. Now when you add these 2 pieces and do a union of strings that are even length in all A's, even length in all B's, if you have that together with this, then you always will make a string that has an even number of A's and an even number of B's in it, and it can be any length string at all, but it will of course always be an even length, but it can be any even length, including 0. So let's see the strings that you can make with this whole thing. Can you make lambda? Yes, because that star says 0 or more. And remember, all the string lengths that you make will be even, so let's not even worry about odd ones. Can you make AA? Yes, because you come in and you just take that piece. So you can make AA. Can you make AB? No, you cannot make AB. So what I'm going to do is write it down and draw a line through it. Can you make BA? No. Can you make BB? Yes, with this piece. The reason we don't want to make these, that our regular expressions shouldn't make these, is these do not contain an even number of A's and an even number of B's. They each contain an odd number of A's and an odd number of B's. So we don't want those. How about length 4 strings? Can you do AAAA? Yes, because you just take that first piece twice. Can you do AAAB? No. And you shouldn't be able to, because that has an odd number of A's and an odd number of B's. Can you do AABA? No. Can you do AABB? Yes, you can. And if you keep going, you will see that the strings that this whole big thing makes are exactly the strings that contain an even number of A's and an even number of B's. Alright, so how do we get started making that machine? Now, it's not going to come out to that pretty machine that we're used to. This machine's going to be non-deterministic. However, if you take the machine that we make from this algorithm and you remove non-determinism from it, and then you might possibly have to minimize it. If you do all that, you will get that pretty, symmetric, even machine with 4 states that we have seen so many times. You believe me? You'll have to try it and just see. But let's get started. Here's our opening move. We make a start state, we make an accept state, and we put the whole big old long, and this one really is long, regular expression on it. Now I'm just going to get you started and then let you finish this one by yourself, because you really need to see if you can finish it by yourself without just having me hold your hand through it. All right. Now, you look for which operation first? Or. Then you look for concatenation, and then you look for star. We're doing it in reverse precedence order. Makes things come out right at the end. Can you get to any ors in there? No, because of that outer set of parentheses and the star. Can you get to concatenation? No, there's just one thing here, and it is starred, and so you need to get rid of that star right there. So what you're going to do is put a new state in the middle, lambda to it, lambda out of it, make a loop on that middle state, and put AA or BB or this big old long thing right here on that loop. And then everything you do is going to involve that big loop. You're going to end up with a machine that has this kind of look and a big old loop with possibly things happening along this loop, you know, states here and there along here, because you've got to, oh, actually that's not true, is it? You are not going to have one big old ring of, what are you going to have? I don't want to mislead you. When you make your big loop, you're going to have that expression written on it, but that is an OR of three things. And so instead of one ring, you've got an OR of three things. You're going to have a piece for your AA part, and you're going to have a piece for your BB part, and you're going to have a piece for that big old long thing. Now that big old long thing really is going to be a great big old chain, because you've got three things concatenated together. So that should end up being kind of an interesting looking machine. I'd like you to work on that, please, and then bring to class this worksheet, please, after you have done this, so that I can give you points for all this work that you are doing. And that will be the points that we had set aside for in class on Friday. So please, I'd like you to do this by yourself and turn it in for points. Appreciate it. Have a nice weekend, and I will see you on Monday if we don't get another big old bad weather.